Hi everyone, we have Ishan Ballar with us from PICT who is joining us for the NLPC Pune webinar. He's going to give us a demonstration on classification algorithm using sklearn. Over to you, Ishan.
Hello, good afternoon everyone. So let's start coding classification algorithm using sklearn. We are going to use logistic regression for coding this. So the prerequisite for this is that you should be knowing a bit of Python, or you should be understanding Python more than knowing it. We'll code it side by simultaneously so that you guys will understand. So we'll be coding in Jupyter Notebook, and we'll use the Pima Diabetes dataset for this, where this can be easily downloaded from Kaggle or any website available online. So here, pregnancies, glucose, blood pressure, up to age are the attributes, and outcome is the label. That is what we have to predict. Uh, so these are we have around 700 something rows. Okay, so we have around 768 rules with us that we can use to train the model. And the problem statement is that using these features, we have to predict whether the person is affected by diabetes or not. Okay, so now let's start coding. Okay, so we'll first create a new IPython file. Is that logistic regression maybe? Okay, so now let's start coding. The first thing that we have to do is data preprocessing over here. Now, what is data processing is, we first have to, it is really important in data mining that the data we have is really good. It shouldn't be a raw data, because when we pass raw data to a good algorithm, we don't get a good model. That is, the model doesn't get trained on a good data, and when it sees an unseen data, it predicts wrong answers. So the data, so bad data and a good algorithm gives you a bad model, but a good data and an average, or even if you don't use a really good algorithm, but still you can get a good model if your data is really good. So first, now we have to uh, have a I have to pre Okay, so first we have to plot the box plot for this.
What Ishan is trying to highlight here is that the data preprocessing is very important while you code any machine language or machine learning algorithm. Data scientists typically observe the data very closely and then prepare a good data to give input to your algorithm or your model. So the first step that every one of us should highlightly and importantly follow is data preprocessing and clean the data.
So now we first have to see the outliers in the data, that we can be use that we can use a box plot for it. So what is a box plot? A box plot provide information about the variability of the statistical data that we have. So basically, what are outliers? Outliers are the observations that are distant from the close observations. That is, for example, if you are collecting information about students from age of around 15 to 25, and you find some observations with people having age 45 or 50. So these we can consider as the outliers, as this is irrelevant to our data set. So this mostly occurs due to experimental or some measurement errors, and uh, the model gets trained in a negative way if we don't remove these outliers. So basically, we can use a box plot for this. So now let's start coding. So here PLT is the alias for the matplotlib, where the matplotlib is used for constructing the graphs or visualizations for our data. And we also need to import the pandas library, which has been already introduced earlier. So now first we need to read the file that we have, that is the CSV file. We have this CSV file which is named diabetes.csv, and we have to plot the data here. So we are constructing a box plot for this, and another attribute is the fixed size for this, which indicates the size of the box plot that will be printing, and plt.show. So we have an error over here. So I think we forgot the comma. Yeah. So now we have these outliers. These three are the outliers, as we clearly seen, as these are really distant from the actual data set. So this we need to remove in insulin, and also this one we can see as an outlier over here, which is the skin thickness. So first we need to remove these outliers. Okay, so I hope everyone has understood what are outliers. So this is the same code that we have written earlier.
I think you might want to explain what
Okay.
you might want to explain what the line stands for, like the insulin line,
Okay,
or
yeah.
what the box stands for.
Okay, so what this box is, that the line that we see over here, this is the median of the data. That is, this is the median of each of the columns that we have. And the first line that we see over here, this is the range of the 25 percentile of our data. And
Yes, so I think that would clarify the doubt. The upper box, the line above the box is 75% of the data, and the line which lies over here is covers the 25% of the data.
yeah, so now let's go ahead. Um, Now we have to remove the outliers that we have seen over here, where these three are the outliers over here. This one is the outlier over here. So now, um, this is typically the syntax for this. So what this line has indicated is that the we'll now have only those values in data frame, or those rows in data frame which have skin thickness less than 80. So what we have estimated over here is this value will be approximately greater than 80. So we will remove this, and we'll also have to remove the values in insulin which are greater than maybe 600. Okay, 600 we can see from the graph. Insulin. Okay. So we'll take all the values which are less than 600 and also print the sheet. So this shape is what indicates the dimensionality. Okay, so now we have removed the four rows in this, and we now have 764, which earlier were 1768. So now let's go ahead. So now we again need to closely examine the data, where you can see that the blood pressure or the skin thickness values have, or the insulin values have been assigned to 0, which is practically not possible because a person dies with these kind of attributes. So we can assume that we have some experimental or measurement errors over here that we need to rectify first before training our model. So the major major ways that we can do this is to replace the zero values with the mean of the column or mode or median, anything, mean, median, mode, anything is possible. So most of the data scientists prefer the median for this, median or mean for this. Okay. So now let's do this. Uh, we are going to use the LOC function over here, which has been explained earlier. Okay. DF of insulin. Okay, so this we can do it for each and every attribute. Insulin, we have glucose, PMI, we have blood pressure, and also the skin thickness. So now we are done with the five attributes that should not be zero but are zero in the data set. So now just will print the DF that we have now. And the first 10 values will print. Okay, so now we have the clean data, we can say. Okay, so now we can see that insulin was zero, or the blood pressure was zero at many places, but now this has been replaced with the mean values of 77 here or 69 here. So we can see that there are no zero values left in our data set. So for this, we can just save to our new CSV, that is df.to underscore CSV. We have a function for this, that is clean data maybe dot CSV, and run this. Yeah, and we'll have the clean CSV over here. And it is here. Yeah, it is here. Yeah, we have over it here. So now we have a kind of clean data. Now the next step is normalization. So now basically what normalization is exactly? So normalization is basically adjusting the values that are measured on different scales and bringing it to a common scale. So what it exactly means is, now looking at the CSV, you can see that glucose values are between around 140 and 85, 183, 116, or but pregnancies are around 1 to 10 or single digit number mostly. The PMI is between around 20 to 50. So these values are between a different scale. So these values need to be brought at a common scale, that is mostly we bring it every value between 0 and 1. So why this is to be done is, since the ranges of the values of this raw data is really wide, so the function that or the model that we want to prepare, won't work perfectly in many cases. So first we need to bring the data into a normalized form. So one of the way to normalize there are many methods to normalize that, the z-score or the min-max. So what we can do is we can just divide each of the column with its maximum value and call it as the normalized data. So now everything is in the first data frame upon data frame dot max. Now what this does is each of the column, it changes the value, that is, it divides the column by its maximum value. Yeah, and we'll just print the dot head for this. Okay, yeah. So now from this we can see that um, now all the columns have values between 0 and 1. Cool. So we'll just even again save this to a new CSV. We can call it as normalized.csv and again run this. We'll have this normalized.csv over here. Yeah, so we have all the values between 0 and 1 for each and every column. That is, now each of the column has some equal bias. Yeah. So now we have pre-processed the data. There are many methods for pre-processing more that we haven't covered, but the data which we have needs this much data processing. Now we'll have to prepare a model for this. Now the first thing that we need to do is we need to uh, get all those values in. So sorry, this is not a CSV. Now the final CSV is this CSV. So now we need to get all these pregnancies, glucose, blood pressure up to age in one as the features in capital X and the outcome in small y, which is the label for us. So capital X is equal to df dot I log. So what this means is that we have got all the values from pregnancies, that is the first column up to the -1 except the -1 column, which is this. This is the Python syntax for splitting that many of you might be knowing. Um, and we'll take the outcomes in one of the in Y, for example. This is a semicolon over here. You can just try to print Y dot head.
We are missing a comma in the D of the title.
Over here.
Yes.
Yeah. You. Yeah. So we now only have the outcomes in this, and we'll just check for X. Yeah, we have everything from glucose. Glucose. So what we have missed on pregnancies over here, so maybe we'll need to start from 0. No, yeah, now we have the pregnancy, so we need to start from 0 over here. Now, uh, we now need to we need some data to train and we need some data to test our model. So we have the train underscore test underscore split method for this, so that we can divide the data into training and testing. So for this, we need to import the function for or the library for this. Okay, so now we have imported this function that we can use to split the data into training and testing. So we can call training data as x underscore train, testing data as x underscore test. Um, Labels for training data is y underscore train, and labels for testing data is y underscore test. So now we'll have to call the train underscore test underscore split function for this, where we'll pass an argument as x comma y comma test underscore size as 0.2. So what this test underscore size is, we will we have divided the data into 80 and 20% of data. That is 0.2%, 0.2 part of the data from one is the test data, which will get selected randomly. So so that for the data to be get selected at random, we need this random underscore state uh, feature for this, which gets set as maybe it can be set as anything, 42, 50, 60. It is actually the seed that is used for selecting randomly the data. So now after this statement, you can see that the x and capital X and small y has been divided into two parts, that is training data and testing data. So now we are ready to create our model. So how is the model created? The model is created using the training function, training data. So x underscore train and y underscore train can be used for training. So we'll create a model for this, and as defined, we need to use the logistic regression for this. So we'll be using a logistic regression for this, and we also need to import the logistic regression function over here. So which is sklearn dot linear underscore model, then import logistic regression. Okay, cool. So now we'll use the logistic regression for this. So the next thing that we use to actually train the model. So the sklearn library has given us a function called fit, which is used to train the model. That is, it has the internal implementation of training the data on this. So we'll just have to pass the x underscore train and y underscore train over there. So what? So you can see that I'll just comment it over for you. The model gets trained using this statement. So now we have the trained model now in model. So now we have to predict on the testing data how correct it is. So model dot predict. We have the internally have the predict method that the sklearn library provides us to predict on the data. So we'll have x underscore test. So we have predicted the values, and we need obviously these values to compare with the actual results which are there in y underscore test. So we'll take that in prediction, maybe prediction equal to y, model dot predict. So although the model has been prepared using the 80% of data, will be used on predicting the remaining 20% of the data. So yes, so we have this. So now we need to measure how right our model has been. So we need to, so sklearn has another method named as accuracy score, that is used for predicting the accurateness of the model. Sklearn.method. So yeah, we have the accuracy score that is used to predict the accuracy of our model, and we just need to call that now. So maybe accuracy is equal to accuracy underscore score. Maybe we'll just write a comment over there, used for predicting test or unseen data, and this is used for predict or calculating the accuracy of our model. So now we have got the accuracy. Now just print this accuracy to see how our model has been trained. Okay, so now we have an error over here. Model get train is not been defined. Oh, what's the it's x underscore train. I'm sorry. Now let's run this. Okay, so now we have got an accuracy of 82%, which is quite good, I think. So now what we have done here is we have first pre-processed the data, then we have normalized the data, and then predicted it. So now you might be wondering why have we done data pre-processing. So now we'll do one thing is we'll write the same data without write the same model without data pre-processing. This that is, so we'll write the same code over here, but now our data frame will not be having our pre-processed data. Data will have data frame diabetes or CP. So here you can understand is that now data frame does not have any pre-processed data. We do not have any normalization in this. We directly have read the CSV file and we are printing the accuracy of the model. Okay, so now just printing the accuracy and we have got an accuracy of 70, almost 76%. So you can see the difference in data, how what the data pre-processing does to our model. This is actually quite a small data, so you can just see a difference of 6%, around 6.5%. But when the data increases, data pre-processing plays a hell lot of role. You can try on various other data sets as well, these models. So that's it from me. I hope you guys have understood.
Yeah, thank you so much, Ishan. I'm sure everybody has understood the importance of data pre-processing. So even if you have a bad model, but you have a very excellently clean data, you can have a better accuracy. That's it from our side. Thank you so much.